afternoon, everybody. How's everybody doing today? Good. Good deal. My name is Trevor Brown. I'm a graduate student at Western Kentucky University. I'm also a data engineer at Logan Aluminum in Russellville, Kentucky. I'm going to get my master's part-time, so it's been a long journey, but I'm excited about where it's been going, so I'm happy to share that with y'all today. So my project is, I call it DashAR or DashAR, whatever you prefer. It's an augmented reality-based heads-up display for automotive. Before I really get going into it, I just want to thank a few people. I want to thank my thesis committee, Dr. Jeffrey Michael Galloway, Dr. Ron Yang in the computer science program at WKU. Also, I'd like to thank Mark Simpson and Leah Spalding, or Leah Moss. She got married recently, but Leah Spalding in the UX and design department at WKU. Isaac Lockwood for his support, and of course my wife, Jill Brown. So to give you an idea of the flow of today's presentation, we'll be talking some about the history of HUD and the automotive instrumentation that's out there. It's been out there since the advent of the car. Some opportunities with this new type of HUD, some of the research that's already been done in this area, some of the process we went behind building this HUD, a demonstration. So I hope somebody has a clown car because we need a lot of space. And then of course, next steps about where this research is going. So with the Ford Model T, which is not the first car, but it's the one that everybody seems to know, it only had one gauge on its instrument cluster, and that was an ammeter for the battery. Other than that, that's all you got. You had to guess your speed, just hope you're going the right speed. Yeah, that was that. There's not much to it. As time has progressed, we've gotten into this, which is pretty common. This is from my wife's Subaru Forester. We have our speedometer, our tachometer. We have actually a speedometer in the middle that's on an LCD display, the fuel level, the current gear, and some mileage information. And then also up in the middle of the dash, we have a clock, the temperature outside, miles till empty, and then climate control information. So with hers being a 2017 model, it has a lot of the newer features in cars, as opposed to my 2013 Hyundai Sonata, which doesn't have all this. So one of the motivations behind this project for me was, how do I get this functionality in my own car? And I think this solution actually helps with that in a lot of ways. Some of the inspiration too got me thinking about films like Top Gun and Star Wars, where you see these HUDs that they use when dogfighting or the targeting computer, when Luke's going to blow up the Death Star. And I thought, well, why haven't we really seen that kind of technology in automobiles? Maybe not the exact same information, obviously, but why don't we have that kind of visualization? So all that in terms of fighter jets and stuff started in the 1940s. With the planes that were used during World War II. They had these scopes that were embedded in a piece of reflective glass that allowed pilots to target their enemies. This particular one was it was taken from Dunkirk, if anybody's seen that movie. It's just one of the dogfight scenes. Which it's hard to see this, but this is sort of what the modern fighter jet HUD looks like. It's electronic, has altimeter and level visualization. Just some really cool looking stuff, if you ask me. But it turns out automotive has had HUDs for a while, or at least a variant of them. The main problem is they're embedded in the dashboard. They reflect up into the windshield so the driver can see what's going on. But also the information is fixed. So you're either going to see just your speed, the turn signal indicator, temperature, whatever. There's just very specific information there. It's not dynamic at all. It's whatever, at the whim of the manufacturer, what they put in. Some solutions to that is you go out and buy an external third-party piece of hardware that you can mount on your dash. But as far as I know, from what I've seen, there's still fixed information. There's not a lot of dynamic information. So this is where this project comes into play. What can we do to sort of offer an experience that's dynamic and can be tailored to any particular automotive application, whether it's just driving every day, maybe something with like auto racing, or something like that. So this was a visual that I came up with the help of a UX specialist on my thesis committee. It's a visual HUD that has three trays technically. We have a tray for critical information, sort of the stuff you see in your traditional instrument cluster. We got a notification tray that's for check engine lights, low tires, alerts, airbag issues, parking brake, anything like that would be displayed on the bottom right. And then the top is more of your, I call it amenity information, just stuff that's nice to know, but it's not absolutely critical to the operation of the vehicle. The prior research that's went into this area, there was some research done in 2009 that utilized a very similar setup to what I'm doing, where there's a computer behind it all capturing data over some interface on the car. In this case, it was the CAN bus interface. For my project we'll get into, I use OBD2, which is Common Diagnostic Interface. Again, information offers that dynamic information that we talked about, but it's still fixed to the dash. Some research in 2006 explored object detection. So another nice application if you're driving and say there's low visibility conditions, having the ability to see something coming on that may not be fully visible. And then here was some research in 2015 that went into navigation in a HUD format. So when it comes to the system itself, there are three main components. You have your car, obviously, with its OBD2 port. Any car manufactured in the US since 1996 has that port available. Whether or not the information available, it varies per car, and as time progresses, more data points get added on that are accessible. But still, any car since 1996 should be compatible with this system. It's the engine control computer is spitting out data over OBD2. We use this OBD2 to USB interface to capture the data. It's fed into this Raspberry Pi. It's running a service I call the data aggregator and server, which is responsible for collecting the data over OBD2 as well as any third-party APIs that might be available through a cellular connection. And all that aggregated data is then called or requested by this, which is the AR subsystem. This is the X-Real Air 2 Pro AR glasses. They're relatively new. They're from a company called X-Real, it used to be called Nreal. They offer AR functionality in a pair of glasses, which is pretty remarkable compared to what we've seen with whole headsets. When wearing these, it's all like wearing a pair of sunglasses. So I can still see y'all, but it's tinted. The nice thing when you're driving it, that's during daylight and visible conditions, these work just fine. Of course, you don't want to drive with these at night, and that's one of the caveats with this system. As time progresses, hopefully solutions will come out that won't require that tinting. The data that goes into this though is captured over Wi-Fi, so the Pi hosts a Wi-Fi network. This phone, because there's no compute on the glasses, this phone does all the computation, and it's also from X-Real. It's called the Beam Pro, and it's pulling that over an API over Wi-Fi. So the DAS, or the data aggregator and server, just a simple REST API that when you connect it to, it can interface with OBD2 and third-party APIs such as Google Maps and navigation. The HUD itself, because there's a dependency on Xreal's SDK, currently this only is supported on Xreal devices, but any of the other classes they have should work with this. We captured 3 levels of data: the critical operation, non-critical operation, and amenities. Critical operations, again, like your speedometer, tachometer, and fuel level. The non-critical is more of your basic navigation and compass and things like that. And then the amenities are like a clock, advanced navigation, and weather conditions and things like that. To manage all this, the PI also hosts an administrative interface that allows people to customize the HUD as they see fit. So we'll see one particular customization during the demo, but the system's designed that you can move these widgets around however you want and select what data you want to pull in. In terms of tooling, from the DAS side over to the HUD, we have Raspberry Pi running Ubuntu server, which runs Python and has the Tornado web server module installed to offer the API functionality. And then the Xreal device runs a variant of Android, which the HUD itself is written in Unity using the Nreal SDK, NR SDK, or Xreal SDK, Nreal. Yeah. And then, of course, all that's programmed in C#. Since this is my thesis, this is just my timeline for my project schedule. I went through the design phase back earlier in the summer. Right now, we're sort of going through an agile development process where we iterate over our different types of builds, seeing what works, seeing what doesn't, and adjusting our design accordingly. My hope is in March, I'll be wrapping up the testing and defend in late March, early April for my master's. So for the demonstration, I'm just going to sort of quickly go over this. I won't be able to play the whole video because it's about 7 minutes long, but I did a route. This is my hometown of Auburn, Kentucky, and I did a route where I went from the far western side of town around Highway 6880, turned back onto Main Street, and followed it all the way back to where I started. So now, I should clarify too, this HUD you're seeing, this is the HUD that we see when wearing the glasses, and this data is in real time as I'm driving, but because there's no good way to record what's on the glasses, this was recorded on a separate PC to offer this kind of visualization for overlay. So as you can see, as I'm driving and I'm turning, I speed up. You'll see the RPMs sort of jump up and then go back down for the gear shifts that are being done by the automatic transmission. The compass, because I was filming this on a computer, doesn't have any compass functionality. So if you do want to see that, I do have all the devices here. Happy to show it to you later. Just find me or request some time. We have the clock, and again the fuel level. And
so is that what you would see inside the glasses?
Yes.
The exact display like that?
Exactly.
Oh,
Yeah. The only difference too would be it is tinted because they're like a pair of sunglasses, but this is what you would see.
Okay.
So for sake of time, I'm going to speed up a little bit. One nice thing about this route is I get a wider array of speeds. I go from like 15 up to 65, and I got turns and stop signs and stoplights, so it offers a lot of good conditions for testing this kind of arrangement. So here was a turn I made. You see me slowing down. back up. Then a little further down, you'll see that the fuel level goes from 20% to 19%. So the way the fuel works is, if you think about it, when you're driving, your gas tank is sloshing around, the fuel is sloshing, but it's not completely full, so that the data recorded is going to be all over the place. So we take an average of a large set of data points, about 1,000 points, to calculate the fuel level. So when the vehicle first starts, and this is one of the things I'm still trying to figure out if I want to show 0 or just hyphens or something that's filler data, and then after a couple of minutes, once the data points are captured, the fuel level can be displayed and updated accordingly. Some of the technical challenges: safe power down for the Pi. Because it's hooked up to a power inverter in the car, the power can drop out when you turn the vehicle off. You know, some vehicles offer some kind of battery pull from over the auxiliary port or the cigarette outlet, for those who know about that. So hooking up a battery of some kind, establishing connection to third-party APIs using a cellular modem or a hotspot on a phone. In terms of the HUD, currently we do data request, a client-server synchronous request. I'm considering switching to a publisher-subscriber model, so we can do some asynchronous stuff with the data that's coming through. Again, implementing that dynamic user interface. And then one thing is, because the phone, this X-Rail device is a third-party system, you're able to access other apps while you're driving. So right now, there's not really a way to say, hey, if you're using this app, you can't use any other app. So there's probably going to be a disclaimer added saying, use at your own risk. The cost of the system, based on this layout, so it uses a Raspberry Pi 5. So it's, for the kit that has the power supply and everything, it's about $160. Power inverter, 150 watt power inverter, $40. Surge protector 10. The X-Rail system was $600, so it came out to about $800. So next steps, by the spring, we hope to expand the HUD's functionality, again with those third-party APIs, offer some additional widgets. The administrative interface will be fully implemented, and then of course testing with human subjects to see how they react to this kind of system. Beyond that, it could be applied to other types of situations, advanced instrumentation for automotive racers, truckers hauling stuff. You know, they want to see their load data. That would be available too if somebody decides to implement that functionality. The computer vision stuff, we've seen that's possible. So getting some kind of pair of glasses with camera involved would help with that. Operations, unsafe speed detection, things like that would be great. And then deeper integration into car over CAN bus. Here are all my references that I used for the project, or I'm using so far. Additional sources, and yeah, that's it. Y'all have any questions? I have a minute 20.
Did you explore, you mentioned earlier about projecting, the older systems would project onto the windshield. Did you explore adding a device that would project their data onto the windshield instead of using the glasses?
That's a great question. I haven't really looked into that. There may be some solutions out there. The nice thing with this system design is each part's modular. You don't have to depend on any particular part as long as the software runs on it. So in the future, somebody could decide, okay, I want a display that reflects up into the windshield, and they wouldn't have, all they'd have to replace is this part. This piece that collects the data would still be the same. So that's one nice thing about this setup. It allows flexibility in that regard. Something I should look into. Thank you for that.
Yeah, I have the same problem, except my truck is 2001, and I love my truck, but I love the technology, and now I'm torn.
Absolutely, and
I toss my truck just to get a new one with the technology.
For sure, and this is where this is targeting that situation. I face the same thing with my vehicle.
I researched my truck and said, no way possible to put the new technology into the truck to get all of the features that too expensive. Yeah, more than $810.
Yeah, that's the thing, driving the cost down too. All right, feel free to reach out if you ever have any other questions about this. Yeah, thank you all for your time.
Thank you.